Uluslararası Geometrik Desenler Çalıştayı'nın 4.'sünü gerçekleştiriyoruz. Buraya gelirken biraz aslında bunun üzerine düşünüp uluslararası ve hususi bir alan geometrik desenler üzerine bir çalıştayın 4.'sünü gerçekleştirmenin gelecek adına ne kadar ümit verici bir şey olduğunu düşündüm. Gerçekten de öyle ve şu an bu konuda bizi bilgilendirecek, sunumlarını yapacak kişi Profesör Doktor Miroslaw Majewski de hayatını neredeyse buna adamış çok değerli bir isim. Yani ben birkaç senedir kendisini tanıyorum. Dil konusunda bir türlü anlaşamayıp muhabbet edemesek de vücut diliyle kendisiyle çokça muhabbet ettiğimiz, çok sevecen ve çok değerli bir isim olarak Profesör Doktor Miroslaw Majewski neden geometrik desenlerin geometrik olarak ifade edildiğine dair sunumunu yapacak ve alkışlarınızla kendisini kürsüye davet ediyorum.
Good morning, everybody. I'm very happy to see so many people here in this room, so many people interested in geometric patterns. And I will try to say a few things related to, let's say, maybe not pure geometry, but at least some geometric aspects. I gave the name to this speech, why geometric patterns are called geometric. Because you see, very often people are talking, oh, I am doing geometry. But when you ask them, what kind of geometry you're doing, they don't know. So let's look at this. In the middle of the screen, you have a very popular saying by Plato, let no one ignorant of geometry enter in. I'm not sure if this is really the proper formulation, because when you go to the books and the internet, you can find really many different translations of the Greek terms. And even the text in Greek that you have here is not really original, because at the moment, not many people can read original Greek characters. Greek alphabet was changing, Greek words were changing, so how far it is exactly like Plato said, we don't know, but the idea is geometry. Let no one ignorant of geometry enter in. This is related also to Islamic arts. In Islamic arts, we use geometry, and we use geometry in many ways. So let's see what I want to say to show you. First, we have two aspects. Probably there are more aspects, but I wish to just concentrate on two only. In the left side, I have one aspect that is purely scientific. You have geometry, you have polygon, you have symmetries, you have constructions, tessellations. And now for the translator. Before coming here, I was talking to my colleagues from Abant University about some mathematical terms that we use in English. And they told me, listen, there are many terms that were never translated into Turkish. So we will be dealing with the words like tessellations, and this word has no translation into Turkish. In fact, there are many different forms of this word in Turkish related to the material. But we have to live with this. On the other side, we have this practical side. This means we have decorations, we have art, architecture, we have woodworking, painting, drawing, carving, various media. And how these left side and right side relate to each other. Just a simple thing. You cannot do a very small pattern with very small elements in, let's say, marble, because this is simply impossible. Material always forces us to change our patterns to something that is possible to do. So patterns in wood, patterns in marble will have bigger elements, and they will have no so tiny details like patterns which we draw on the paper, for example. Material is really important. I will be mentioning mostly the left side, but you have to remember about the right side, because the right side is really important. Now the names. You see, the West always had problems with names. And the West invented so many different names which are not always correct. Sometimes they are totally wrong. For example, one of the first books is talking about Islamic art, geometric pattern in Islamic art, and I think this is the most proper formulation. But then we got to Bourgogne, with the book which he wrote, Arabic Geometrical Patterns. Come on, just tell me, what about Persians? What about Uzbek? What about others? They didn't do any patterns, only Arabs. You cannot just relate and say, that's Arabic design. Sorry, that's not true. You see, very often I deal with mathematicians talking about Arab mathematics. And I always fight with them because there's nothing like Arab mathematics. There is mathematics created in the region, and the people who were creating it were from different nations. This type of mathematics does not belong to Arabs, it belongs to everybody in this region. The same is with patterns. Then you see Hankin in 1925 invented another term, Saracenic art. Come on, how this is related to geometric art in this geometric patterns in Islamic art? Saracenic. Who are Saracens? Saracens, according to my understanding, are these people, the Bedouins, who were fighting around, okay? Did they create any patterns? So that's the thing. When we are looking in Central Asia, we have quite a number of scientists living in Central Asia, in Samarkand, Tashkent, Bukhara, and they use different terms which are, let's say, more proper. For example, Gaganov is talking about geometric ornament. And for him, geometric ornament, it is every ornament that was created with the geometry. And that's fine. I have no problems with this. Then, in Balkan of work, you find the name Gierich. There are a few versions of this. They say Gierich, Gierich, Gierich. Why? Because this is the Russian influence. This is always the same. You remember, when the Westerners have a contact with the Middle East or Far East, they never hear properly some sounds. So they invent something similar. So the names like Gierich, that's a Russian term used by Rempel, or Gierich in English, okay, or Gierich. These are the names that are just Russian translations, but this is fine. We understand what is going on. Then when you are in Iran, the most proper name is Gerech. Gerech is used by the source that I admire the most, the Encyclopedia Iranica. This is a very professional source, and whatever is there, I know it was checked hundreds of times by scientists from Iran, and for this reason I prefer to use the name Gerech, because Gerech for them means two things really. One thing that it means, it is pattern, geometric pattern. But the word Gerech has also its another meaning. It is not. But you know what you do? You're taking pieces of wire and you just combining them together. These patterns are like knots. You see here, you have combination, you have junction, here you have another junctions. And here we see only the pattern. We don't see the geometry in the background. But gerech means really making knots, making knots, making knots. But then in the West we have Islamic geometric patterns. I always wonder why they just use this naming. Probably just to have better selling of their books, okay? Because they believe that if they put Islamic, many people will be just grabbing these books and buying, and that, which is not really true. Okay, let's go further. So, what really means geometric pattern? Let's look at a very simple example. This is the example that you can find in many countries. I took it from Istanbul. I really appreciate the art that I find here in Istanbul mosques. And the first thing is that when you look at this pattern, I draw here two lines, vertical line and horizontal line. And these two lines are splitting this pattern into 4 identical parts. You can see easily this part is exactly like this one. It is a mirror. You know what is mirror? When you're looking at the mirror in your house, you see yourself, and this is you, this is your in the mirror. Your left eye or ear in the mirror is the right eye or the right ear, okay? So you have this type of geometry. Reflection. This is mirror, and this part are just reflections of each other. Then you have horizontal mirror, and the top part and the bottom part are reflections. So that's the first geometry then when you see. When you look at any pattern, always try to identify where are the mirrors. If you find mirrors, then you start understanding how the pattern was built. But out of this picture comes one important idea. If you want to make a pattern like this, you don't need to make the whole pattern. You just need to take 1/4 of it, construct 1/4, and the rest you have. The rest is just copy, copy, copy. So we have mirrors. And when you will be walking through Istanbul mosques, especially the big Kundekari doors, each of them is built just this way. Mirrors, mirrors, mirrors, and left and right reflections. Look at this pattern. This is another pattern from Istanbul, and look how many mirrors you have here. You have vertical mirrors. This part and this part are the same. This one and this one are the same. They are just mirrors, mirrors, mirrors. So you are like in a room with many mirrors, and you see many reflections of something. Let's say element like this is enough to make the whole pattern. You don't need anything else. You don't need to think about the whole cosmos. You just have to concentrate on this part and think how this part was made. So you have multiple mirrors. And by the way, having a piece like this, you can create big pattern as you want, or just a small one with 4 pieces like we had before. So mirrors and global reflections, I call this global reflections, are important. Now you have another pattern from the doors here again in Istanbul. Istanbul is full of such things. This pattern was taken from of one of the sultans near Hagia Sophia. You know, near Hagia Sophia there are, I think, 5 tombs, and at least in 2 or 3 of them you will find really great patterns. So when you have time, go there, because this is the place where it's really worth to start. And now look at this. You have here 2 lines. One line, one type, this is the red line. And you have also yellow lines. Why two different colors? Because you see, the red lines are showing global mirrors. Left side from the red is the same like right from the, okay? But also you have something that is not exactly a full mirror, but it is just work locally. Look at this. If you compare this part here with this part here, how similar are they and how different are? This shape you have here, this shape, it comes here, this one comes here, then this one, it comes there, this one comes there, okay? But this part is different. This part is different. So this is symmetry, but this is just a local symmetry. But the local symmetry like this is giving us something marvelous. Because when you look at this pattern, you can say, okay, I can do many things with this. For example, if I take only this part, just only this part, if I ignore the rest, I can create my own pattern just built out of this piece. But I can also take this part between red line and the yellow line. I can create another pattern built out of this. So this was the way of ancient masters. What they were doing, they were combining different patterns together. This was the whole engineering thing. Very often they had pattern that was built out of many pieces, and each piece could be used to create completely separate pattern. So, for example, when you are in the mosque, when you look at the big Kundekari doors, you see really two patterns. You see the main pattern, and then you see the pattern that is at the bottom, a small one. And very often the pattern at the bottom, this is something that was taken from the main pattern and just used to make something separate. Okay, let's go further. For the person who is running this thing, I would like to ask you to stop me when there will be my time over, okay? Here you have different pattern created out of brick. If you look at this, you will find that the mirrors are hidden somewhere because they are not vertical, not horizontal. They are slant. They are like this. You have here mirrors. But there are also special points in this pattern. The yellow circle is just showing the place where this square that you have here, or the whole pattern, can be rotated 90 degrees. You rotate it in this point, you just put a pin into this point, you rotate 90 degrees, and you will see nothing changed. Pattern is still the same. You rotate again 90 degrees, again pattern is the same, nothing changed. So there are, in many patterns, there are special points where you can rotate pattern and you can get something that looks identically like this, what was before. So not only mirrors, but also rotation points are important, because rotation points sometimes are even more important than mirrors. Here you have something that is related again to global and local symmetries. These are the doors from Selimiye, a mosque in Edirne, but I found the same patterns here in Istanbul. I put here on this pattern red lines and these big polygons like this one. This is a decagon, 10 sides, because this pattern has a global mirrors, global symmetries, but also if you take something that is inside of this thing, what you can do, for example here, okay, I cannot reach up, but for example here, I can put a mirror like this, and I can flip it, okay? Not the whole pattern, just this part in the middle. So this this pattern has areas, only areas that has their own symmetries. And you can just look at this. This is a typical tenfold symmetry. You can put through this pattern 10 lines like this, okay, 10 mirrors like this, and you can flip the pattern, just this what is inside of this decagon, about any of these lines, and you will still get precisely the same image. So that's a local decagonal symmetry. Just try to stick to some names. Decagonal, because deca means 10, so this is the tenfold pattern. Pattern that are using decagons like here, we are talking about them as a decagonal patterns. By the way, that's not so simple. You will find that this is more complicated than it looks like this. But anyway, this is your next stop point. When you are in the mosque, when you look at the doors, try to identify the areas which are related to local symmetries like this one. Decagonal has 10 mirror lines, but you can have also other types of symmetries. The pattern in the top, it is a very specific one. Again, the central part, I didn't put here the decagon because I want you to just do it. So the central part is the decagonal one, the central rosette, but the whole pattern is not. The whole pattern has only 2 lines of symmetry. Here you have a nice thing that has, again, just look how many symmetries you have. 1, 2, 3, 4, 5. So this, again, decagonal pattern. You can put there 10 symmetry lines passing through the center of this shape, and you can flip your pattern about any of these lines. Here I put something different. I put here something with 9 sides. You will find many patterns with 9-fold symmetry. Usually we use the word D and the number saying how many mirrors you can put in this pattern. So the shape like this has 9 sides, it has 9 symmetry lines, and there are many patterns with this particular feature. And here you have a treasure. This pattern is really a treasure. Why? Because in this pattern there are no mirror lines. You can do whatever you want and you will not get mirror lines. Okay? But I put here 2 circles, and these 2 circles are showing you that around the central point, for example, the bottom circle, and in the middle there is a swastika. And the swastika in the center point is the rotation point. That's a 4-fold pattern. Only 4-fold pattern, okay? And for example, if you look at this, this is the point where you can rotate the whole pattern 90 degrees. 90 degrees, nothing will change. Pattern will look precisely the same. But of course, you can do it about any of these points that you are getting like this, okay? So that's a very specific pattern. In fact, there are not many such patterns. You can find them, let's say 100 or 200, but the patterns with mirrors are the most popular. Why? You see, that is something with our brain. Our brain likes things that are symmetric. So quite often you will see elements that are symmetric, symmetric, symmetric, and we used to look at the mirror symmetry. That's exercise for you. Look at this pattern and try to establish what kind of symmetries you have. Do we have here mirrors? Do we have here mirrors? Definitely there is one mirror just going this way. How many horizontal mirrors you have here? That is one here. There's no mirror below. Then another mirror you can put in this place. Then another mirror you can put through this rosette, and so on, okay? So this is the pattern with so many mirrors, and in fact, if you wish to make this pattern, if you want to draw it on your own, you don't need this whole mess. You just have to think about this small area. This is what you need. Just a small part is enough to create a universe. And here is something that Professor Selçuk said to us. If you make a mistake, it will look wrong. If by any chance you will make somewhere a tiny mistake, the whole pattern will repeat the same mistake, and it will be totally wrong. I will come back to this topic later because otherwise I will talk too much. That's pattern with 12-fold symmetry, dodecagonal. If you look at the big rosette, the huge rosette that you have here, it has 12 petals, okay? If I call this part as a petal, you have 12 of them around. So that's a 12-fold symmetry, completely different than 10-fold symmetry. It is absolutely different world. 12-fold symmetry patterns are different than the 10-fold. They have different features, different properties. But you can also find in this pattern 4-fold symmetry. If you take this part only, and if you use your imagination, suppose that this part you will flip down, that this part here will form a symmetry, local symmetry, which has 4 mirrors only, okay? But you don't see this because this is just a small piece. Let's go farther. That's another pattern, and that is a pattern which is using 16 mirrors and 8 mirrors as a local symmetries. Okay, so this is not decagonal, this is not dodecal. The best is just to say 16-fold symmetry because we understand the word 16, but if we start using the Greek names for different symmetries, then many of us will not remember what's going on. And again, just look at this pattern. You have here centers. That's another one. Here is another center. Here is another center. If you take a square from here to this, then to this star, and to this one, this is everything what you need to make this pattern. You don't need the whole universe, just this small piece, okay? And then with this small piece, you can do whatever you really want. That is a nice pattern. I couldn't find a better version of this pattern. You have 8-fold symmetries, and then you have 16-fold symmetries. Usually, we call this pattern as an octagonal pattern, and that is fine, okay? Octagonal patterns use 8 and multiplication of 8. It means 8, 16, and up, 32, and so on, okay? All of them we usually call octagonal patterns, okay? Even if they have higher symmetries, we usually. So that's something that we call octagonal pattern, but we have octagonal and hexadecagonal local symmetries in this pattern. In this moment, I would like to stop for a moment. Look at these shapes. Each of these shapes, this is Kundekari work. It means each of these shapes is wooden. And each of these shapes has its own symmetries. For example, shape like this. This is separate piece of wood. And here is mirror. Bottom part and the top part are identical. If they are different, Sorry, our mind is just telling us that's wrong, okay? If you see something that where this part and this part is different, we are just concerned about accuracy of this pattern. Is this really a good pattern or not? I will come back to the good and bad patterns later. That is another treasure, very difficult to find. This pattern is using 6-fold symmetries, 3-fold symmetries, and suddenly is using 5-fold symmetries. Why? Because you see, originally, this is the 6-fold pattern. It means hexagonal pattern. But then they used pentagon, perfect pentagon, to decide how these lines will be going on. With this, there is no problem because the pentagon is located in such a way that its back is just like this. So here we have a part that is with the 3-fold symmetry perfectly well done. But then you have the rest of the pattern just around this pentagon, and for this reason, these sides, these lines are not getting straight like we used to think, okay? They are just slant. And this is design that you can find in Egypt. I didn't find anything like this here in Turkey. But don't worry, I will show something from Turkey, which is also very interesting. This Moroccan pattern, 48 symmetry, 12-fold symmetry, 6-fold symmetries, 8-fold symmetries, 4-fold symmetries, very complicated. And the patterns like this were never created in one piece. They were always created with some different patterns, just parts put together. Sometimes we are dealing something where a mirrors doesn't really work. This is the example. You're looking at this pattern from the distance and you say, okay, that's a hexagonal pattern. You're right. This is hexagonal pattern. But it does not have mirrors. Why? Because we would like to have here a mirror like this. Can we have it? No, because if we flip the pattern left side with the right side, this point will change, the orientation. Here, the line is going up over this line. If you flip it about the mirror, you will have different direction, okay? But we don't need really to bother about this. This is just the artistic touch. Very often you get patterns with some extra artistic touch that just break mathematics. But do we have to have everything mathematically correct? No, okay? That's another pattern. That's another pattern with typical 6-fold symmetry, and I just was marking the shape that you can rotate 60 degrees 6 times around, but it does not have mirrors. So if you want to create this pattern, you have to just create this part that is inside of this hexagon and then repeat it all over, okay? That's the only way of, no, well, not only way, but one of the ways of making this pattern. So, naming. We talk sometimes about patterns which are hexagonal, octagonal, decagonal. Sometimes you have mixed patterns with mixed symmetries. I said in the beginning that this is more complicated than only one. There are many options and many ways just to talk about local symmetries. Now, sometimes we deal with the patterns where saying that this is hexagonal pattern is extremely difficult. This is octagonal pattern is really difficult. Why? You have a pattern here. When you look at this pattern, definitely you say, what is this? I don't see any symmetries. I see only mirrors. But then what I did, if you draw a decagon, if you take part of the decagon, So this piece in the red line, it is precisely this one. So this is the pattern that was derived on decagonal patterns, but many people will not see this decagonal feature. They will just see something that is quite nice and quite nicely done. This is really nice work, okay? Let's say one more word about geometry. I was talking about geometric features just for everyday viewer. You're going to the mosque, you're looking at the pattern, and you should be able to recognize what is what, okay? You should be able to distinguish some pieces. But then you have many other geometric features. For example, proportions. I always say to my students, patterns were not created for the sky. Patterns were created for the particular purpose, for the particular space. Patterns on the doors, on any doors, cannot be any size. They have to fit the space that was left by architect for the pattern. You cannot make wider pattern because it will not fit. You cannot make taller or shorter pattern if it does fit. So here comes something quite important. When you're designing pattern, you have to relate it to the space that you have. If you don't look at the space, if you don't consider the space, you will never get things right. And this is what I like here in Turkey, because Turkish patterns are mostly decagonal. Why? I like this idea that Ottoman architects used. Decagonal patterns are expandable. If you have a decagonal pattern and you like it, you can always add a piece and make it taller and taller and taller just to fit the space. And you can do it many ways. And you can find that patterns on the doors here in Istanbul usually were constructed in such a way that there were added pieces just to fill the space. But you have also divisions of angles. For example, here you have pattern and this shape was divided, this angle was divided into 5 equal parts. Not many people see this, okay? Not many people see this. You have using circles. Quite often you see pattern with so many circles drawing on them. Why? Because the circle is the best tool to move the distance. If I want to have this distance from here to here, move around, I just make a circle, and then I look for the points of intersection, and I have this segment and this one are the same. This is the role of circle. Move around and move with the circle distances, segments. Then you have lengths, then you have polygons. Every pattern is dealing with polygons, okay? So here, for example, in this pattern, you have nice pentagon. You can check it. This is really nice pentagon, okay? It means regular pentagon. Each side is the same length and each angle is the same length. So we are talking about polygons. Each pattern is a tessellation also. You have many polygons and they are combined together. Okay, I think you have enough of geometry. Let's go far. My question is how much time I still have? How much time I have? Okay. Wrong or correct? I put these 2 words and capital big one, 2 different colors. Why I did this? You see, very often, really very often, some people are telling, oh, this pattern is wrong. It's badly done. This design is wrong, okay? It's not correct. And especially in the West, you have a few gurus who will be telling you what is correct, what is wrong, what is not. You see, they saw 100 patterns, they saw probably 1,000 patterns, and they just made a rule. Pattern should look like this, like this, like this. They are not open for surprises, for something different. So I wrote here in the yellow, do not criticize. First, try to understand what was the artist's idea. This is the most important message from this talk. First of all, we don't have really a book where somebody from the past, I mean the middle century, wrote, pattern should look like this, this, this, and this. There's nothing like this. Whatever is, we have a lot of examples and nothing else, okay? We have scrolls of architects, we have examples on the doors and the walls. We can use our brains to make some rules, but are we sure that our rules are really true? Probably not. So, there are no written rules saying what is correct, what is not. I said be observant. It means look at different patterns, compare different features, and just think how it was done. Every pattern can be created with different rules than the rules that we establish. Okay? We cannot expect that we are thinking the same way like the people from the past. We are slightly different, okay? We are slightly different. So, in the last point, I wrote something that is important. First, use your own sense of aesthetics. This is what we have. We have our brains, and we have our own sense of aesthetics. So use our own sense of aesthetics for the pattern and say if you like it or not. If you say you don't like it, say what you don't like. Particularly, try to identify what you don't like. So again, try to understand what was the artist's idea. Now, if you look at the typical pattern, a typical pattern in our brain is related with symmetries. This is why I was talking about symmetries, symmetries, symmetries. For example, if you look at this star, nice hexagonal star, if one part of the star will be longer than the rest, you will say, that is wrong, it should not look like this, okay? You will suddenly notice that something here is not really good, okay? But this one is perfect. Even if you look at these shapes, this shape has two symmetries, nice. This shape has at least one symmetry line, okay? So our brain is just working in symmetries. We are not Japanese. In Japan, quite often art is asymmetric. It does not have symmetry, quite often, not always. Our brains are working always on symmetries. So this is our preference. Here you have another example. Look at this. On the first look, you have a feeling, oh, that's a mess. No, that's not a mess. And suddenly you see, that's a mirror, that's another mirror, here is another mirror, and then you have swastika, you can rotate it. This is referring to our sense of symmetry. And this is deep in our brains. And now I'm coming to something which I took from the magazine. The magazine is, the journal is the Young Scientist, year 2014, page 161. Two authors, I didn't put names of the authors, made something like this. Look how ugly is this thing, and look with your senses at this thing. For example, the shape in the first red circle. We would like to have it symmetric. Our brain is telling us that is wrong. This should be symmetric. Left side and right side should look the same. If you look in the middle kite like this one is correct, okay? But this one on the left is wrong. Then you have another red circle. Again, this shape is lacking something. It looks ugly. And then you look at the blue things. this part and this part, they should be identical, but they are not. And there is even more. Look here, that you have vertical line. Fine, I like this vertical line. But where is this vertical line here? It is gone. You have part of it, and in the top, it's gone. So definitely you can say that is really wrong. And here there's no question mark. This is really wrong. But many people are doing like this, okay? Okay. Here is something. That's a Bibi Hanim, Samarkand. And I have pattern which is quite doubtful. What is wrong with this pattern? Look, for example, here. You have two shapes, and our brain is also telling us this part should be exactly like this one. Yes? They should be symmetric, but they are not. They are different. Then you have another red shape, and inside of the red shape you have this blue thing, which is lacking symmetry. It has rotational symmetry, fine. My question is, why? Why somebody made a pattern like this? The reason was the space. The artist who was designing this pattern had unusual space. The proportions of this side to this side is 1.5. It means 1.5, okay? Which is wrong for decagonal patterns. This is decagonal pattern. If you look at this, that's a nice decagonal star. You have decagonal symmetry here. But because of the space was like this, designer had to adjust the pattern. I can reconstruct this pattern exactly the same way. I can show you when you are getting these things. For me, if I just skip the aesthetical part, I know how this thing was done and why it was done. I understand this. Many people will not understand this, and most of the people will just pass this pattern and they will never see that there are errors in this pattern. That's something that is my favorite one. If you are going to the Topkapi Palace, one of the main gates, you will find this pattern. This is the photograph taken from the Topkapi Gate. I'm not sure if you can see it now, because yesterday I was walking near Topkapi Gate and I saw that they put iron covering all these gates. I think this is after all these nasty cases that happened here. Some of the doors are just protected from bombing. But anyway, that's a very nice pattern. And many Western designers will tell you, that is wrong, that is wrong. What's wrong with them? Not with the pattern, what's wrong with them? I am saying what's wrong with them, not with the pattern. You see, this thing, then they don't like the idea that the lines are connecting together, not like here, for example. One line continues here, another one continues here, no bending, nothing, okay? Here, these lines are just bending here. This is perfectly okay. You can justify. If you look how the pattern was constructed, it was constructed in a very hard way. Believe me, reconstructing this pattern is not an easy task. I really had to work some time to get things properly done. But, so when you look at this, never give up, never give up. Try to understand why this pattern was made this way, how to reconstruct it, and then you will find something absolutely marvelous. With this pattern, I can create something like this, for example, okay? This is the same idea. The same idea, using these 3 petals combined together with the shape like this. That's perfectly fine. I can deal with this, and I can make many patterns with the same motif. Okay, another pattern. This is something I was fighting with many people about this, and they say, that is wrong. That is wrong. Now, my question is, how it can be wrong? This is not a new pattern. It is not a pattern made in the 20th century. This is 17th century pattern. This is a traditional Ottoman pattern, and it was done by people with very high skills. And what they say to me, it never should be like this. This part is wrong. No, it's not wrong. You have to understand how it was made. You see, some time ago, about 2 years ago, Ayhan sent me email with this pattern, and I took it, I reconstructed it. But I didn't like it. I didn't like my work. Why? Because I lost symmetries of some elements. For example, here, look at this. This one has a nice symmetry line, nice mirror. Top part and the bottom part are the same. When I reconstructed it first time, it lost the symmetry. I didn't like it. So I had to spend some time reconstructing it again, and I made it. I even invented 2 methods for making this pattern. This is my reconstruction of the central part. This is not really everything. This is on the next picture. This is the part that was taken from this line to this thing, and then, so I reconstructed here only the central part just to show the idea. And I call it patterns with twins. Okay, designing with twins. Why twins? Because you have 2 identical shapes just touching each other side by side. Not corner by corner, but side by side. This is a really very nice feature. But trust me, it is not easy. Remaking this pattern is not easy because you have to establish completely different proportions. Here is another pattern, and many people will tell me, that is wrong. Why? That's a traditional ceramic from Bursa. In the Green Mosque in Bursa, you will find this pattern. And what people don't like in this pattern, they don't like these connections. They say, this connection is absurd. It should not be like this. And in this moment, I say, no, you have to think how you got this connection. So if you try to reconstruct this pattern, if you try to make this pattern again, but just fixing these connections, you can fix them. There's no problem with fixing them. Then you will get something like this thing in the top. Okay? This is the same pattern with changes related to this particular place. I made it. It looks like this. What is the problem really with this thing? The elements, okay, I have to find them. The elements that are for this one here doesn't look this, nice. If you look at this corner, right corner, the shape, it is fat, it is ugly, okay? So I understand that designer of this pattern preferred this version over this version because this one is ugly. But you can also make this pattern this way. Instead of putting star, you can put a hexagon inside. If you put hexagon inside, this shape will turn to something like this. It is nicer, okay? It is nicer. It is nicer than the top one. You can even, instead of octagon, you can put inside here the dodecagon. Yes, do I am right? 1, 2, 3, 4, 5, 6. Okay, that's a 12 size. You can make it like this. Again, that's about aesthetics. You're getting shapes like this. If you like them, That's up to you. You can live with this, no problem. Okay? So every solution that you see on traditional patterns has its own reasons. And these people were really thinking about this, what they are doing. Okay, so before criticizing a pattern, try to understand the artist's concept. Open your mind for new ideas. That's important. Open your mind. Don't be narrow-minded. Just open your mind, and then you will discover a completely new world, absolutely new world. This, what you will discover, is not standard, is absolutely unusual. And this is everything what I wanted to say today. If you have any questions, you can ask now, if we have time. If we don't have time, you can ask questions during the lunchtime, or you can ask the questions later, anytime. I'm happy to talk with anybody. Thank you very much.
Türk İslam mimarisindeki geometrinin kristal kuvarsitleriyle ilişkisini açıklayabilir misiniz?
Well, many, let's say, people related to physics are trying to relate patterns to, let's say, modern discoveries in physics, especially in crystallography. But you see, there are some similarities between some complex patterns and the things in crystallography, and these have only common part, the geometry. Simply, crystallography is based, images in crystallography are based on decagons and other features, regular polygons, and this makes them similar to Islamic, to the patterns in Islamic art. But I don't think that there is any other relation, just similarity.
Affedersiniz hocam, yani bu geometri rastgele bir geometri değil, bir yaratılış geometrisi olduğunu görüyoruz. Yani kan hücremizin, bir göz dokumuzun, vücuttaki bütün organlarımızın temel yapısı nasıl bir sistematize edilmiş bir ölçü, ahenk ve insicama bağlı ise, bu geometrinin de rastgele, Türk İslam mimarisindeki bu geometrinin rastgele değil de mutlak bir ilahi kanunlara bağlı olarak düzenlenmiş olduğu konusunda ne düşünürsünüz?
From the geometry point of view, we have quite a lot of possibilities to make variations. When I get a pattern, a photograph of a pattern, when I look at it, my mind starts growing, and I can create quite a lot of things. Just from one photograph, I can make a number of different patterns, because these are the ideas that are coming. This is evolution. How it is related to our body, I don't know. I don't know.
Thank you very much, dear Professor, for your very aesthetic presentation. And let me introduce myself. My name is Yurdagül Mehmetoğlu from the Cyprus University, Cyprus Social University. And I'm interested in illumination a little bit. Maybe that is the a little bit specific question. That is, I think that. What is the edge between the artistic touch and wrong patterns? Could you explain it? I couldn't understand exactly that. Sometimes you have shown beautiful patterns, and you said that that is wrong, but it's very aesthetic. What is the, how can I separate between them? I couldn't understand. Thank you very much.
as I said, there are no written rules. What is correct, what is wrong. You have to use your own sense of aesthetics, what you like, and why you don't like something. This is never a situation like this that you don't like everything. There's always something that you may not like, and you have to just understand why I don't like this. That's all. You see, about 5 years ago, I went through so many patterns and I created rules, some rules. And I wrote, I think, 6 rules at this time. What I see in the patterns, I don't say that these are the rules saying that the pattern is correct or not. I wrote rules describing major features of the patterns. But even with this, over the time, my rules were evolving, were changing. So you have to just stick to your own judgment.